Okay, hey guys. Today I am going to go over our notes. We're going to talk about parallel and perpendicular lines so that when you're in class with me and we're working on this stuff, we all know a basis of how they work, and we've got our notes to refer back to help us as we practice things in class. I have attached, as always, a picture of the notes. However, they're not fully filled out, so the notes have blanks in them. So as we go through this video, I need you to fill those out, and I'll check that when you come into class. So for parallel lines have the same slope. So in this first blank, you're going to write same. So that basically means that they're moving in the same direction. They're never going to run into each other. So think in the word parallel, you have two L's that are side by side that just run parallel to each other. So that helps me remember that parallel never touch, and they're just two parallel lines, like railroad tracks. So they have the same slope, which means they're both moving the same way. And because linear functions, the lines are straight, there's never going to be a point where this line just starts to curve, or else it wouldn't be parallel, right? So let's look at the slope of line A. A is our pink line right here. So from this dot to the next dot, we go up 6 and to the right 4. Well, we know that up is a positive direction, and to the right is also a positive direction on the x-axis. So the slope of the line A, which is rise over run, would be +6, +4. But we know that 6 over 4 actually reduces. So if you divide both of those numbers by 2, 6 comes down to 3, 4 comes down to 2. So you can actually reduce the slope to 3 over 2. And if you look, if we start at this dot and just go up 3 over 2, up 3 over 2, we do run into our pink line right here on the axis. So you can actually get to a sooner spot on this line if you just cut your slope in half. And then if we look at the B line, the slope of the B line, from this point to this point, we go up 3 and over 2. So that would be 3 over 2. So these two lines are parallel to each other. They have the exact same slope. They will never run into each other. So what we fill in right here, lines A and B are parallel. They move the same and will never run into each other. In an equation, lines that have parallel slopes have the same slope. Okay, so I wrote it up here. Parallel lines have the same slope. In an equation, lines that have parallel slopes have the same slope. So when you're looking at an equation, it's got to have the same slope. And we know this right here is our slope, right? That number in front of the x. So if I've told you that I have a line, and the equation of that line is y equals 2x plus 7, can you tell me another line that would be parallel to this line? Now, the only thing that we know, or that you know so far about parallel lines, is that they have the same slope. Everything else can be different, but they have to have the same slope. So y equals 2x plus 4 is parallel because it has the same slope of 2. This one starts at 7 but has a slope of 2. This one starts at 4 but has a slope of 2. As long as that matches, everything else can be different. What about y equals 2x minus 400? Still parallel. This is the starting point, so this line's going to start at negative 400. This line starts at 7, but they both have a slope of 2, so they're never going to run into each other. So as long as they all have the same slope, everything else can be different. Well, just the b value. There's really not much else. And then the last thing I want to go over is how to find the equation of the line that's parallel to something when they want you to go through a specific point. So sometimes they may just say, like up here, tell me a line parallel to this line. And all you have to do is write another equation of a line. But sometimes they're a bit more specific and they say, I want it to be parallel to this line, but I also want to make sure that the line that you're about to write the equation for goes through a specific point. So at this point, you have to plug in not only the slope, because it has to be the exact same, but you have to plug in this point as well so that you're going through that point. So we know our equation is y equals mx plus b. So we are going to first plug in the m that they gave us, the x that they gave us, and the y that they gave us into our formula that we already know. So if we have y equals mx plus b, I'm just plugging in the values that they gave me. Now some of you may say, where did they tell you the slope? Well, they told me that it is parallel to this line. And we know if it's parallel, it has the same slope. So they told me right there, it's got to have that slope. So that's how I know. It's got to go through these 2 points. So I also know that I have to use those two. So in my equation, y equals mx plus b, I plugged in the y equals the m, the x, and I don't have the b. So 1/2 times 0 is 0. Anything times 0 is 0. Well, 0 plus b is just b. So b is 2. So now that I know my slope and I know where this line has to start, 0, 2, I can write my equation. Y equals 1/2 x plus 2. These are the 2 things I need to know. Now this was a trick because 0, 2 is actually your y-intercept. Remember when we talked about tables and I said if you ever see 0 on the x side, whatever that y value is, that's your y-intercept. If you see that, you can plug that right in for your b value. But if not, and you forget that rule, you can always plug things in and solve. And so the last equation in your notes, you need to write this down so that when you come to class, it's done. But it says find the equation of a line parallel to y equals 2x plus 4 and passes through 4, 12. So you're going to pull this slope because it has to be parallel to it. It has to have that same slope. You'll pull this x value and you'll pull this y value. You'll do exactly what we just did here to get your equation of the line. And that's all for your notes.